Dun 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 dun. Dun, 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 dun. So, to start our little expedition, we gotta go over to Graffville in Canada. No one knows why it's over there. No one knows if it's over there. But that's where we're going, to Graffville. So let's get started. Boom! Hey, it's your boy, K-Easy, K-Money, K-Dollars, whatever you want to call me. But today, we're going to be graphing the minimums and maximums of a graph. Because I, especially, put the max in maximum. That's my middle name. So yeah, let's start on how to find the minimums and maximums of a graph. So, what is a relative minimum and maximum, you ask? You probably didn't, but anyway. A relative maximum is the maximum value of a function, the place where the graph has a vertex at its highest point. The relative minimum, the minimum value of a function, the place where the graph has a vertex at its lowest point. Meanwhile, absolute maximum is the highest point over the entire domain of a function, and the absolute minimum is the lowest point over the entire domain of a function. Basically, looking at the graph on the right, the maximum is the highest point, the minimum is the lowest point, and the absolutes are the continuous rise and fall of the graph. Before you find the secrets to all this graphy goodness, you should know a few skills such as using a graphing calculator comfortably, like knowing where your buttons are and how to use them, whether what calculator you have or not. Know how the domain and range work, as in domain goes from left to right, and range goes from bottom to top. You need to be able to read a graph, especially, because that's what we're going to be doing today. And know what you're looking for, of course. And you have to be able to change the window setting to a perfect view of what you're looking at. You got to know where you want it so you can get what you want out of it. And to use your graphing calculator to find the max, you pull up your graph. For example, negative x squared plus 3x plus 5, as shown to the right. Go to your second. Graph it first, of course. But then you're going to go to your second, the trace or calc button, number 4, which is maximum. You're going to move your pointer all the way down to the left. And then from there, you're going to move your pointer all the way to the right. And you get that little column of where you want. And then you're going to guess where the max is. And then boom. That's what your answer is, right there. Easy peasy lemon squeezy. Now, to use your graphing calculator to find the minimum, you're going to pull up your graph and put in, for example, x squared plus 3x minus 5. You're going to graph that, of course. Then you're going to go to second, trace or calc, then 3 this time for the minimum. You're going to bring it all the way to the left, all the way. And after that, you're going to bring it all the way to the right. And you get that little column there. And after that, you just guess where it is, and boom, there's your answer. right there. Okay, now using what you've learned from the previous examples and demonstrations, find the minimum and maximum of the graphs below. Pause the video so you can take a stab at it, and remember to fix your window for the appropriate points, and press play when you want to figure out the answer. So, you should have worked on the problem and hopefully found a solution, but we're going to check right now. So bring up your graph and enter the function as you did. So 3x squared minus 12x plus 9, and graph it. I seem to found out that if you set your window to a -3 for the x min, a 7 for the x max, and a -10 and a 30 for the y min and max, and the y scale to 5, you get the perfect solution, or perfect window for the 1 and 2. So you're going to hit second, calc, and min and max. Well, this one's only minimum, so find the 2 points next to your minimum area, and bam, that should be your answer. X equals 2 and y equals -3, which you could round. And now you're going to go to your next problem, clear that off, and you should have x cubed minus 6x squared plus 9 and plus a 13. I'm just kidding, it was a 15. Gotcha. And see, it perfectly graphs with the window that I found. And you're going to go second, calc, or trace. You're going to find maximum first because it's to the left, and it's just easier. So you're going to find the left and right side of your maximum, relative maximum. And bam, there is your answer for the maximum. It should be 1 and 19. And now you're going to go over to the same thing, but I hit maximum. Darn it. Brain fart. And you're going to go to minimum. And you're going to hit the point left and right of your minimum. And bam. You just get x equals 3 and y equals 15. So if you got the solution for the first two, you're on a good track. You're ready for graduating math school. Yeah. And lastly, for solution 3, you're going to bring up your graph. 2x cubed minus 9x, and graph it. And for this one, it didn't work with the window I had before, so I'm going to change the window. Y3 is -3 is fine, or x -3, x3, and you don't need a -10. Well, you need the -10, you don't need the 30. And then a 10, and graph by 5, and bam, perfect. So you're going to go second, trace, maximum, all the way over to the left side. Enter. And then all the way to the right side. Enter. And then you get your maximum, which is -1.22 and some change, and y equals 7.34. Then you're going to hit minimum. You go down, get the left side of the minimum value and the right side of the minimum value. Down, enter, bam. Well, it's the same thing, just flipped. thank you for watching this long, drawn-out, relative minimum graphing video. And I hope you learned something. But shout out to Mr. Plots for the great knowledge. The knowledge he taught me that will pass on to you, and hopefully with that knowledge you could get a Lamborghini one day. Thank you to Desmos Online Graphing Calculator to provide the graphs, the TI-84 that helped get the job done, and the keynote for MacBook Pro, which was used to make this. And this was a Math Keegan Productions. Thank you for watching.